Hey, good morning, and good morning to all you guys. We have 2 rock lessons today, and the first one's going to be using this form. 3 types of rocks, so please get that out. You guys have in front of you. You need to fill in the answers as I go. I will also show you some rocks as we go. So first of all, there are 3 types of rocks. The first is igneous rocks. And igneous rocks can be either intrusive, I will spell it for you, I-N-T-R-U-S-I-V-E, intrusive. I'll spell it one more time, I-N-T-R-U-S-I-V-E, intrusive. That means they are formed inside the earth, okay? The other word for intrusive is plutonic. Do you see it there? Yeah. Plutonic. And then they could be extrusive. Extrusive is spelled E-X-T-R-U-S-I-V-E. E-X-T-R-U-S-I-V-E. And that means they are formed outside of the earth. So with me, please, go intrusive, extrusive. Stand up and do this, please. Igneous rocks can be formed inside the earth, which is intrusive, or outside of the earth, extrusive, which also means out of a volcano. So do extrusive, volcano. Okay, have a seat.
Writing this down.
You're filling in the blanks, honey.
What? Where's intrusive and plutonic?
Thanks for helping her out. So the other word for extrusive is what? Can you see it on the sheet there? Volcanic. So you think inside the earth, extrusive, volcanic, or in a volcano. Okay, so igneous rocks, letter B, they start out as hot liquid rock, which we call magma. Magma is hot liquid rock. Or lava. So here's the difference. Magma is formed where? Underground. And lava is formed above ground from a volcano. By the way, you'll find magma down in the mantle layer. We have never reached the mantle layer yet. We'll talk about that later. We get to plate tectonics. So they either start as hot liquid rock, magma, or lava, and then they cool. Letter C. Here's the difference, though. The longer they cool, did you write that in there? The longer they cool, the larger the crystals that can form. Crystals is C-R-Y-S-T-A-L-S. Crystals. The larger the crystals that can form. Now I have 4 examples, and all the examples on this paper you have to know by sight. You have to know what type they are as well. I have 4 examples of igneous rocks for you. The first one is called basalt. And let me spell that. B-A-S-A-L-T. Basalt. B-A-S-A-L-T. I'm going to show you the basalt right now. Basalt. Notice they are kind of dark and boring. Basalt. You guys will have a chance to look at these more later, okay? Basalt. Letter A. Basalt rocks are dark. They are dark. Did you see how they were black? They're usually dark. And they're mafic. Mafic is made up of 2 words, magnesium and iron. Anyone know the chemical formula for iron? Yes. It's Fe. So do you see the fic in the mafic? It comes from iron. So magnesium and iron rocks are called mafic rocks. Letter B. Basalt also cools fast. It cools fast. So because it cools fast, the crystals don't have a lot of time to form. So although these basalts have crystals in them, you can't see them with the naked eye. They're just too small. You need a microscope. Because it cooled fast. They didn't have time to form. Very large. Letter C. Basalt is the most common rock in the oceanic crust. Let me spell oceanic. O-C-E-A-N-I-C. Oceanic crust. And if you have a question, you can ask. And so that's it. So that's basalt. So one more time. What do we call this rock here? Basalt. Does it cool slowly or fast?
Fast.
Are the crystals large or small?
Small.
Is this the most common rock in the oceanic or the continental crust?
Oceanic.
Oceanic crust. Very good. Are they light or dark?
Dark.
Very good. The next igneous rock I have to show you. Oh, yes, Polly.
What was A for the one?
Dark.
Oh, dark.
Yeah. The next rock is obsidian. Obsidian. It's do a spell it. Go ahead.
I have so many obsidians in my
Cool,
house.
you have some. Yeah, that's because for where you come from, there's a lot made there too. Obsidian, O-B-S-I-A-N. O-B-S-I-A-N, obsidian. No, that's wrong. O-B-S-I-D-I-A-N. I'm sorry. O-B, start over. That's my fault. O-B-S-I-D-I-A-N. Obsidian. What's your question?
Yeah,
What was the answer to A?
Dark.
Basalt?
Dark. Okay, so under obsidian, obsidian cools in seconds. I'll show you this. It cools in seconds. Look at this gorgeous, shiny black.
Looks like clay.
So it's also really, really, really sharp. Because it cools in seconds, it doesn't have time for the crystals to form. So the other name for it, you're gonna write this down, letter B, volcanic glass. They call it volcanic glass. Volcanic, V-O-L-C-A-N-I-C, glass, volcanic glass. Crystals cannot form. It cools instantaneously. The minute this hits the air, it cools and it makes this glass. Doesn't even have time for the crystals to form. Volcanic glass. So what do we call this? What's the technical name for it? Obsidian. Obsidian, volcanic glass. Is your question related to this volcanic glass?
Yes.
Yes.
If it hit the air and water, would that make it stone?
Still a rock. Stones are rocks. Also, a fun fact. Surgeons. Aren't your parents surgeons in here? Surgeons, many surgeons use obsidian for scalpels. Ask her if she uses obsidian knives. Ask her about that. They're very sharp. So many surgeons use obsidian for scalpels. Addison, go ahead, put your finger on that. Right here. You feel that? That's sharp. And that's not even polished with anything. I mean, that's just naturally sharp. Yep.
How hard is it to get a knife or a diamond and sharpen it even more?
It takes work to do it, but it's very effective. Okay, the third igneous rock I have. Remember, they're either intrusive or extrusive. Oh, by the way, backing up, is obsidian extrusive or intrusive? Extrusive. So put an E next to it. It's extrusive because it forms outside of the earth and volcano. How about basalt? Intrusive or extrusive?
Intrusive.
Did you say intrusive?
Extrusive.
Extrusive on a volcano. Okay. Next one is not extrusive. The next one is called granite. 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 Granite happens to be the most common rock in the continental crust. You can find it just about everywhere. It says granite. Now, it also says the word pegmatite there. Pegmatite, so a pegmatite is a granite with huge crystals. So this is a regular granite, the kind you might find on the ground. But this is a pegmatite because it has huge crystals on it. So granite and pegmatite are the same thing, but this pegmatite has the huge crystals of granite. Let's learn more about granite. Letter A. It cools in thousands to hundreds of thousands of years. So is that a fast cool, guys, or a slow cool? Slow cool. These beautiful crystals take a long time to cool. Long time to cool. So they are formed underground. Why do you think it takes so long to cool? Kellen? Well, it is intrusive, but why is doing intrusive rocks take so long to cool?
It's hotter.
It's hot down there. It's hot down there, right? It's hard to cool in a hot place, so it takes thousands, hundreds of thousands of years. Letter B, because it takes so long to cool, you get crystals, or you get crystals to form. So when you see the big crystals, that's usually an intrusive igneous rock. Letter C, granite is made out of 3 minerals that you know. The first is quartz. Q-U-A-R-T-Z. Q-U-A-R-T-Z. So it's made out of quartz. It's also made out of feldspar. F-E-L-D-S-P-A-R. These have stars on them because these are our test rocks. That's why they have stars. Feldspar. Anyone know the other mineral that you can see in granite? Say it if you know it.
Mica.
Mica. Mica. We have mica. So quartz, feldspar, and mica. Now I'm going to pick this pegmatite back up. Can you think? Can you see the white quartz in there?
Yes.
Can you see the pink feldspar?
Yes.
Can you see the black mica?
Yeah.
Is it shining?
Yes.
Yeah. Yes. Granite is made of quartz, feldspar, and mica. Even in a small one, can you see the pink, white, and the black? Sure you can. You can't see pink, white, and black in there?
No.
Oh, now I can.
Yeah, now you can. Sure. Okay. All right. Is that an extrusive rock or an intrusive rock? Intrusive. Put an I by the word granite there. And finally, our fourth igneous rock is called pumice.
Wait.
D. Sorry, going back. D. It is the most common rock in the continental crust. Sound it out. CONTIN. No. Yeah. ENTAL. Continental crust. The most common rock in the continental crust. Our fourth rock is called pumice. 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 Not pumice. It looks like pumice, doesn't it? Pumice. Pumice is another word for volcanic ash. So when ash comes out of a volcano, it has a lot of air in it, and it forms these bubbly rocks. So these pumice pieces have bubbles. Lots of bubbles. Open your hands out. Catch. Is that really heavy rock? Is that dense?
Yeah.
It is? It's
No,
dense.
no.
No, it's not dense. It's lightweight. It's lightweight. Many pumices will float on water. Some pumices are used to scrub your feet. What is your question?
Is pumice kind of like coral because it has like
Pumice looks like coral. It is not coral. No, it is not coral, but it looks a little bit like it. It's not a sponge. A sponge would soak things up. This is a rock. It doesn't soak things up, okay? But it has bubbles. It's hard like a rock. Yep.
I believe I had a piece of pumice.
Okay, it's very possible that you did. All right, so is pumice an intrusive rock or an extrusive rock? It is an extrusive rock. It is volcanic. Yep, because of a volcano. Okay, we're doing the time here. We're at 12. It's a long video. Okay. Sorry, guys. Hang on. It's a long lecture. All right, our next set of rocks is, what's on your sheet there? Metamorphic. Metamorphic means, and next to it, write changed form. Changed form.
right here.
Yep, and then the line next to metamorphic. Metamorphic means changed form. Morph is to change, meta is change form. And metamorphic rocks are changed by heat and pressure. Heat and pressure. Heat and pressure. Heat and pressure make more metamorphic rocks. You take a lot of heat and pressure, and it's heat and pressure underground, by the way. Does it say that there?
Yeah.
Okay, heat and pressure underground. So they're formed underground by heat and pressure. They are changed. There are other rocks that have changed their form. So make sure you understand this. We're not starting out with magma. We're not making igneous rocks. We're starting with rocks that are already there, and then they have heat and pressure applied to them. Your first example is this rock right here. This is called schist. Spell it, please, and spell it correctly. SCHIST. So, if I say to you, oh, schist, I am talking about rocks, okay? I'm not swearing at you, all right? So this is schist, SCHIST. What do you think schist is made out of? Go ahead and say it.
Tiny mica.
Yeah, so you got the sheet there, tiny mica crystals. So if I take micas underground and they get heat and pressurized, they're going to form this schist rock. Schist is harder. Metamorphic rocks are much harder than other rocks because they've been heated and pressurized. So a bunch of micas heated and pressurized and squeezed are going to become schist. Your next metamorphic rock that has been changed form is called gneiss. 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 Hold your question, please. Now remember, metamorphic rocks used to be other rocks. Anyone want to take a guess? Let me ask you. Let me give you a little quiz here. I'm going to show you a piece of gneiss. This is a piece of gneiss. It is banded, and I'll explain why it's banded in a moment. But can anyone tell by the colors what rock gneiss used to be? Ava, give it a shot.
When it used to be what was it? Granite?
Used to be granite. Gneiss used to be granite. Now let's see where we are on the sheet. So it used to be, oh, it says on there. It used to be granite. It has dark and light bands. Now, unlike sedimentary rocks where you have one layer, then another layer comes on top, another layer, this is not what bands are. This is not what bands are. Bands are where you take a rock, like granite, and you heat and pressurize it and squish it, and the minerals start to align themselves in different patterns and bands, okay? So these bands are not layers, they are bands. The minerals kind of come together and form banding. Can you see the pink? Can you see the feldspar?
Yeah.
Can you see the white, the quartz? And the shiny mica, yeah. This used to be granite, it is now nice. It's a very nice rock. Thank you, thank you, thank you.
Honestly, that
Thank
was
you.
funny because it's
Thank
the
you. All right. I know, that's one of my favorite jokes. All right, so if you, oh, I also have it here. This is also a piece of gneiss. The white, and it's usually light and dark bands.
Are you
See
saying
that?
knives?
Light and, pardon?
Are you saying knives?
Nice, nice. Like N-I-C-E, but that's not how it's spelled.
I had a joke. I had a joke when you
Okay,
showed
next
me.
one. The next one is another hard, remember metamorphic rocks are hard rocks, is slate, S-L-A-T-E, slate. Now slate is this stuff right here. It is hard stuff. People use it for their roofs, slate roofs. They used to be used for chalkboards. Listen to the sound of the slate when I put it down.
I love that.
That is slate. That's a very hard rock. Slate used to be shale. Shale is a sedimentary rock. It's not slate. Listen to the sound of shale when I put it down on the ground.
Sounds like
Do you hear the difference?
Lasting.
So here's the shale.
Wood.
It's mud. It's just mud. Here's the slate. Can you hear the difference?
Yeah.
Yes, sure you can. So slate used to be shale. Slate used to be shale. Which is harder?
Slate.
Slate is harder. Okay. How are metamorphic forms? Metamorphic rocks formed by two things. By what?
By
Heat
pressure.
pressure.
And pressure. Good. Are they formed above ground or underground? Underground. Okay. We're going to take a stretch break and get back to sedimentary rocks. You guys too. And then come back.
We still have number.
Sorry guys, we're back. I forgot to give you guys number 4 on metamorphic rocks. The fourth metamorphic rock is this one, which you often find on your counters. What is this? Marble. It's spelled M-A-R-B-L-E. Now marble, of course, is a changed rock, so it used to be something else. What do you think marble used to be? It's on the sheet. It used to be limestone, and limestone is a sedimentary rock that may have fossils in it. Now calcite fizzes in acid, doesn't it?
Yeah.
Limestone's made of calcite, so limestone fizzes in acid. Marble used to be limestone. You think that fizzes in acid?
Yeah.
It does. It really does. But where the heck is mine?
Can you show us?
Uh-huh.
We need the acid.
I think I see it.
That's okay. Actually, in one of the later videos today, you're going to see me actually put the hydrochloric acid in, but this will also fizz. So marble used to be limestone. So very quickly to review, schist used to be
Tiny
mica, gneiss used to be granite, slate used to be shale, and marble used to be limestone. Okay, the third type of rock is sedimentary. These are my husband's favorite kind of rocks. These are formed by letter A. Water carries sediment, S-E-D-I-M-E-N-T, and eventually what's it?
Deposit.
Deposits it, right. We talked about this when we did weathering and erosion.
Position.
It deposits, it's right, deposition. Deposit, D-E-P-O-S-I-T-S, deposits it. So water carries the sediment and eventually deposits it. Eventually the layers harden and compact.
What?
Harden, H-A-R-D-E-N, and they compact, C-O-M-P-A-C-T.
What was after
sediment.
And over time, more layers pile up. So, let's do some motions with this, okay? So water carries the sediment. Let's do it. Water carries the sediment and eventually deposits the sediment. The layers harden and they compact. And over time, the layers pile up. Okay, one more time. Water carries the sediment, it deposits it, the layers harden, compact, and over time pile up. And compact means they smush together, right? For those of you who are brainiacs, there is another word for harden. I want you to write it down if you want to. Lithify. Lithify. L-I-T-H-I-F-Y. L-I-T-H-I-F-Y. That's lithify. So when rocks harden, geologists say that it's lithification. Okay?
How do you spell again?
L-I-T-H-I-F-Y. Greek word for rocks, lithos. It's all lithography when you study rocks. All right, back to it. All right, so another thing about sedimentary rocks is they are made of other rocks and sediment. Sedimentary rocks are made of other rocks and sediment. Because it's sediment that's carried down, of course, it's made by sediment, made of other rocks and sediment. I have 5 examples of sedimentary rocks to show you. The first is the one that's made of sand particles. And sand particles, by the way, are mainly quartz. I have 3 of these. And this is sandstone. Notice the layers on this piece of sandstone, and it feels like sand. Here's another one. You're going to see this in another video. It is sandstone. Yes, sir.
Isn't sandstone just compact sand
Yep.
and then hardened by lightning
That's
or quartz?
Not lightning. Did you say lightning? Not by heat.
Pressure.
Over time, they just compact and it's not metamorphic. But you do. I guess you do have a sense of pressure of pushing down on top of each other. But there's no outside force going. Argh. It's just because over time the layers keep depositing, they start to compact naturally. There's no heat or pressure causing it. Not outside pressure. It's just one layer here, another layer here, and over time they start to press down. And you'll see the layers here like this. Yep.
What does it sound like to put down?
It'll be a heavier rock, but that trick is only for slate and shale. Yeah.
So if you said sand's like mostly made of quartz, well then a diamond made of sand, so that's mostly made of quartz?
Eventually, well, carbon. That's a whole other story. It's made of carbon. Diamonds are made of carbon, honey. Quartz is made. So, back to the sandstone, made out of sand particles. Feels sandy. Also has layers. It's not on there, but it has layers. Number 2, used to be mud. We've seen this one already. It's shale. Shale. S-H-A-L-E. Shale. It's very brittle. It breaks. Be careful with my shale. If you drop it, it'll crack. If you could pick pieces off. Please don't. Shale's very brittle. It's easy to find. Like it looks like mud. Number 3 used to be calcite. Usually has fossils. Limestone. Limestone. L-I-M-E-S-T-O-N-E. Here are 2 pieces of limestone.
Oh.
There's a gastropod fossil, so we know that's a piece of limestone right there.
Wait, for number 3.
And here's a coral. So this is a coral fossil. This is limestone. You need to raise your hand if you have a question for me. This is a gastropod fossil. This is a piece of limestone. It will fizz in acid when I get the acid. What's your question?
Nothing.
Okay, thanks. Number 4. Used to be organic carbon. Or is organic carbon.
Quartz.
This is stuff,
Oh.
organic stuff like leaves and dead things that over time have compressed. Coal. Okay, used to humus, great. It was humus at one time. Very good, Kellen. It was human at one time. All this organic stuff. Humus. H-U-M-U-S. Organic stuff used to be living, like plants and animals and stuff, dead stuff, over time turns into coal. Yes.
Isn't it like something like when you put coal, if you put inside a volcano and wait like 100 years, it'll turn into diamonds or something?
You're talking about a whole different process. So let's hold off on that one, okay? This is not, now coal, I'm sorry, coal will eventually become diamond too. So is that what you're asking? Yeah, eventually, yeah. Because it's carbon, so over time that can be changed as well. Yes.
Oh, so you said that's made of dead things.
Is it possible for like a human to die and his body to turn or her body?
Sure, humans go back to the earth as well. So
So you could be holding a person right now.
I could be holding people right here.
Ew. I thought
That's fun. I don't want that.
Okay.
Yeah.
More likely that the human remains sort of dissolved, didn't get trapped. Humans are more likely to be able to escape from stuff. Okay, number 5, a rock made up of other rocks is your last one. You know the name of it?
Granite.
Good. That's a rock made up of different minerals. This is a rock made up of other rocks, and the name of it is a conglomerate. Let me spell it for you. Ready? CONGLOMERATE. One more time. CONGLOMERATE. Conglomerate. So it's a rock made up of other rocks. This rock has got all sorts of pebbles and rocks and stuff stuck together. All right? That's a conglomerate. Fun fact. If you have a big company that's made up of a lot of other companies, it's called a conglomerate. There you go. That is all we're going to do on this paper, because now we're going to go to this paper, which is a whole nother assignment on Google Classroom. The problem is, folks, I forgot to attach this paper to the 4 videos. So when you pull out your 4 videos, make sure you have this sheet in front of you. I did send it in a separate assignment, but you need this in front of you for the next lesson. Okay, ciao, ciao, goodbye.